Hey guys, you are going to need your activity guide from lesson 4 to follow along. Um, and a couple times throughout the video, I'm going to ask you to pause it and try to do some of the questions and filling in some of the things on your own. Please take advantage of this, okay? Really take the opportunity to try to do some of these things on your own and then see how you do afterward. Just like I would ask you to do if we were in class together during this time. You know, I'm going to do a few and then I'm going to ask you to try some on your own. So make sure you're taking the opportunity to really see what you are learning and what you understand as we're going through this. The other thing that you're going to want handy is the good old Flippy-Do. It's going to help us as we're building our binary numbers and being able to convert back and forth from binary to decimal and vice versa. Okay, so we are going to first fill out this chart of 4-bit numbers. So you can see that we've started with 4 zeros, which is 0. 0, 0, 0, 1 is a 1. And remember, on our Flippy-Do, our first 4 place values represent 1s, 2s, 4s, and 8s. So if I have 0, 0, 0, 1, that means I just have a 1. To write a 2, that means I just want a 1 in the 2's place value. So 0, 0, 1, 0. Now, how would I make 3? I don't have a 3's place value. Well, if I have a 1, 2, and I have a 1, that would give me 3. So 0, 0, 1, 1 gives us 3. Okay, my next number would be 4. So let's take a look at the Flippy-Do. Hey, I have a 4. So that gives me 4. 0, 1, 0, 0. Okay, how am I going to make 5? Well, if this is 4, I only need one more to make 5. So 0, 1, 0, 1 is going to give me 5. If I want to make 6, a 6 means I need a 4 and a 2. So I'm going to have 0, 1, 1, 0. 0, 1, 1, 0. All right, 7. How do I make 7? Well, 8's too big. I don't want an 8. If I take a 4 plus a 2 plus a 1, 4 plus 2 plus 1, that's 7. So 0, 1, 1, 1. Okay, I want you to pause the video and try to fill in the rest of this table on your own. So pause the video and use your Flippy-Do. You could look at the pattern of what's happening. How are the numbers being built? I want you to try to come up with what are all of our numbers in binary from 8 to 15. Okay, hopefully you did these on your own and took the time to try to figure these out. Okay, now let's take a look at this next question here. What do you notice when you compare the odd numbers with the even numbers? And what might explain this? Okay, so you can go ahead and pause the video and take just a few seconds to look at the odd numbers compared to the even numbers and see if you can see any patterns and figure out why that is the way that it is. So pause the video. Try to answer it on your own. Okay, hopefully you paused the video and took a look at the numbers. And what I hope you noticed is that the even numbers end in 0 and the odd numbers end in 1. 0, 2, 4, 6, 8, 10, 12, 14. Those all end in 0. And all of the odd numbers end in 1. Now, why is that? Well, with the even numbers ending in 0, that means there's not just one added on. In the odd numbers, there is. So the 1 added at the end makes the number odd. That's what makes the number odd. Okay, let's try the next table here. Binary numbers with exactly 1, 1. Complete the chart with all 8-bit binary numbers that have exactly 1, 1. We've done the first two for you. So again, you can take a look at your flippy-do. The first one, remember we build our numbers from right to left, okay? So if I only have a 1 in the ones place, then my number is 1. If I only have a 1 in the twos place, then my number is 2. So what's my next one? Well, that would be if I have a number in the fours place, which would make that 4, okay? So 0, 0, 0, 0, 0, 1, 0, 0 is a 4. Let's do one more together. If I put a 1 in the next place value, that means I have 1, 8. So this number here is 8. Okay, pause the video, fill out the rest of this table on your own. All right, hopefully you paused the video and were able to fill all of this out. Check your work, make sure it looks good. What pattern do you notice about the decimal equivalents of all of these? As the 1 moves one place over, our number doubles, right? 1 to 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32, and so on. The numbers double. Okay, let's go ahead and flip over the paper. You are going to be completing the rest of this on your own before I see you again this week. So you are going to take these binary numbers, figure out their decimal equivalent, and then you're going to take these decimal numbers and find their binary equivalent. Now, a couple things to note is that some of these bigger numbers there might actually be more than 8 bits that you have to use. Okay? So you might have to imagine that there's extra place values to the left here to build that number correctly. So you're going to have to do some problem solving to think about it. One thing to note, in normal numbers, we call them digits, but that's base 10, okay? Base 10. In base 2, we call them bits. Base 2, those are called bits. So this is a 3-bit number, whereas here, we call this a 3-digit number, right? So this is a 3-digit number. This is what we call a 3-bit number, okay? Just a little vocab for you. So you're going to use your Flippy-Do to help you do some conversion of the numbers, and you are also going to answer these questions here. When I see you again later this week, I'm going to be checking that you have this whole paper done, both the front and the back. Make sure that to make sure you took good notes and you answered the questions. We will go over everything together when I see you again.